This video is the continuity of how multi-master failover works. So in previous video, we understand how does etcd cluster works and how are its failover and leader election process happen. So we understand all these 3 points along with these two labs. So uh, there was a mistake in the previous video when we calculated the minimum number of required members to do the election in case we have 48 etcd instances. So it will not be 23, it will be 25. So 24, 48 divided by 2 plus 1 is 25. So this was just a small mistake, but I hope you got the idea how this calculation is happen. So in today's video, we have to understand about the next component, that is the API. So why we understand the etcd first? Because etcd is the heart of our Kubernetes cluster. It maintains the states. It's a key value based database. So uh, and the whole concept of cluster failover is revolve of the control plane failover is revolved around the etcd. Rest of all components are just communicating with a etcd database. So now we have to understand about API server connectivity with etcd database and decide about the healthy state of the etcd cluster. So how API will connect, we will understand this, and what is etcd client library, we will understand this, and we are going to perform these two labs. Lab with etcd level failure, uh, mean if we fail the etcd, what will be the effect, how does API behave in the absence of etcd. So this will clear some more concepts that we understand in the previous video. So let's start. I have Kubernetes cluster and I have 4 master nodes, same cluster I am using what I used in the previous video. So first of all, my uh, kubectl client utility is connecting with the load balancer, and this is the state of the load balancer, and we can see here the API backend. All 4 master instances are healthy, in healthy state and are connected. And just to look in our the configuration, the environment variable regarding the kube API kubeconfig. So this is the kubeconfig file, and here I define the IP of my load balancer, so that all the requests are going to load balancer, and then load balancer is deciding which API can respond us in the multi-master node. So, so to start, we will understand how API server connect with the etcd databases. So under the etcd Kubernetes manifest directory, we know this is the file that contains the static pod information about the API server, and here uh, it's it's there is a configuration of etcd servers, and by default when we are setting up the multi-master nodes, the very previous video in we did the installation of multi-master nodes, and in that video we have not understand about how the etcd and API and scheduler and controller behave in the multi-master node. We just understand how to install it. So in that video we have not discussed in depth about these configuration. So in this file there is a configuration etcd servers, and by default when we are setting the multi-master nodes, the, the API server is connecting directly with its locally hosted etcd server. This is the default behavior, but this is not the recommended method. It should be changed. I mean, it's this API server should know how all the etcd instances. So what is the disadvantage of using this setting? If the etcd service is stopped on this local machine, then the API server of this local machine will be down because there is no other point of contact for the etcd server. So it should be, I'm setting the IP of my master node 1 and comma separated I can give all the other master nodes. So my master node 2 is 5, master node 3 is 6, and master node 4 is 7. I'm just changing this and saving it, and kubectl get pod hyphen a, and I'm just going to grab a API. So API master node is up. It will, and just let me check the kubectl logs of this pod in this namespace kube system. So it is giving us the error because I just changed the configuration, and whenever we are changing the configuration it will be down for a while. It will restart. So we can see on the dashboard it's down now, and when it will be up it will try to connect with all the new etcd. And now let me just take a look on the logs. So it will show us to which etcd instances it is trying to connect. Okay, so now it is up, and it just took some time, and here we can see the resetting endpoint master services Kubernetes to all these IPs. And let me just do a -F to see the real-time updates happening in this pod. So now we can see it's up and it's reconfigured. So just I need to do the same setting for all my API servers. I'm just going to copy this configuration for all my API server on all my master node. So this setting you have to change if you are running a multi-master cluster. This will not be by default in the multi-master cluster setup that we did. Just changing it will automatically restart. This is my master node 3, this is my master node 4, and I have to open this file. So I change in all my nodes. So all my API server will go down whenever you are changing in anything you are changing in the static pod, it will restart. So this is done. Okay, so now we have to understand how API server connect with the etcd. So we just discussed about the configuration so far. So how API server knows about the master, the elected nodes of elected instance of etcd services, all the etcd instances. So I am going to run the same command that I ran in the previous video to just get the information how what is the current state of all the etcd instances and which one is acting as a leader. So right now 107 is acting as a leader, and its value is true. So leader is now responsible to write the data in the cluster in the etcd database, and rest of all members will just replicate its data. So the question is, how does our API server knows that which one is the leader? So there is a built-in etcd client utility in the API server, that is the etcd client library. It's just like a client and utility, just like we are using etcd ctl. It's for us, but especially etcd client library is designed and hard coded in the code of our API server container, so that it can automatically understand which node is acting as a master node, as a the leader. So when I showed you this setting that was previously this one, so this was the set as localhost. So when it was connecting to the localhost machine, even though it was not the leader, so lead that etcd respond the all the leaders IPs, just like we query and we get all the members and leader members IPs, and as well as the information about the leader. So that etcd client library will inform the API server that this is the leader and you have to connect only with this leader to write the data. So in that case, it will then re-query to this elected leader, even though we set the local host by default in the configuration of the API manifest. So when we write all the IPs, so it will query to all the IPs. If first one is down, it will query to the second one. If second one is down, first one, second, and the second down, third and fourth, it will follow the sequence. But at the end of the day, the target of API server is to find the elected leader to write the data. So this was the concept about how API server is connecting with the leader. So now we will do a test, and we are going to again run the logs of our one of our master node for the API server, and we ran the command, and we know this master node 4 is right now acting as a leader. So I will not shut down the leader first. I will first shut down any member, just like worker node 2, master node 2. So let me just shut down the etcd of this node, and let me just do a query on this from any node I can do, and let's see what is the current state of all the etcd. So still we can see the election does not happen again. The masternode 4 is etcd is still acting as a leader, rest are as a member. But here in the logs we can see this API server is consecutively trying to hit the failed node where etcd is shut down now, and it's trying to connect with the 2379 port, and 2379 is the port that is used for the end user for the connectivity with the etcd. So API server will consecutively respond that this server is not reachable. Okay, now these logs are going on. Let me shut down the etcd database on the node that on the node that is acting right now as a leader. So on 107, I will shut down the etcd, and this time we will observe that the error message is, I'm just doing a control C here, the etcd server no leader found. So this is the proof that the client library, etcd client library, which is integrated in the API server code, that is automatically processes this redirection leader address. So automatically the API server comes to know that there is no more leader remains in the etcd, and the API server now will not be able to write any new request. Even we cannot query anything new from the cluster. If we try to do a kubectl get nodes, the API server is trying to hit to etcd, but etcd is not responding. So now let me just run this query again, and there will be only two members, and they cannot do the election. Why they cannot do the election? You can see the uh, last video. We discussed this in detail, and they are not just working as a member. So now we understand this the API server connectivity with the etcd database. So we did this lab with etcd level failure. How does API server behave in the absence of etcd? If the member we lost, it will just error that it's not available. But in the leader failure, it will stop working. And we are looking here in our HA proxy. All the API servers will now come up and down, up and down. Why? Because this log that I showed you, it will try. Let me run this. I hope, yeah, this is now down because it is keep retrying, and the retrying process is by the health prop that this uh, 2379 port should be reachable. So if this is not reachable, it will restart the API server. Again, it will try, again, it will time out and restart. And this process will continue until the etcd will not come back. So now you see, this is now down, master 1. 2 and 3 just completed its retry cycle, and now they are started. So you will see here all the nodes will keep retry and restart. There is a specific timeout defined in the manifest of API server. You can see. And if you are looking, if you are working as a multi-master administrator, so you should not only depends on this dashboard, the green status of the API server. Or if all the API server are green, or even though one or two are green, and you are trying to query the kubectl get nodes and you will not get the response, it's mean there is some issue in the cluster, and the command that you should use to troubleshoot is this one. From any node, you have to look into the logs of the etcd, sorry, the logs of the API server, and then you must have to run this command according to your environment. You will definitely change the endpoints for the etcd, and this will give you the right answer. What is the reason? So let me just again run the logs. It is still down, and if I run the master 2 static pod, it seems like it is also down. So now master node 4 is resetting its connectivity. So now let me just bring back one of my this etcd. database. It will just take a while to be up. Let me query. It is still down. It will take some time to just bring up the service. Now it's up. Quorum member are full requirement fulfill, and one is elected as a leader. And if we just look into the logs, so you can see the API server is back to work, and just it's giving the error in the configuration. This is defined, but it's not reachable. And all the API server will be back to work as soon they will restart and will get the healthy state of the leader. So this was the concept and the relationship in between API server and etcd. Now the next thing we have to just understand, whenever we are querying from the command line like kubectl get nodes, anything we are query to API, now it's responding. So although you can see here some of the API are still not up, the request is going to load balancer, and then load balancer is uh, sending the request to the healthy API servers. Okay, so if I shut down in the etc Kubernetes manifest, and if I just shut down the kube API servers, I just shut down here, and I will do the same exercise in my master node 2. We'll see here these two will be shut down. Yes, both are down, and still I am able to do the query to my API server, and API server is connecting to my etcd. So how it is happening? Because the load balancer is now taking care of all the requests of the API. Even though if we have lost two of API, it's still working. So you can query any API server directly or by the load balancer. But if you are doing directly, definitely you need the healthy one. So I'm shutting down the third one too. Let's see its status here. It's also shut down, and let me query to API to get nodes. Okay, so right now load balancer is sending requests to the last one left behind. And if I shut down the last one too, just so it will now, all the API servers are now down, and if I query, this time it will not work. So how you will now troubleshoot? You will look the logs of the API server, as well as you will run this command to see the status of your etcd databases. So database is good. Quorum is members, required member are there. Leader is there. It's mean there is some issue in the API server. Okay, so we are done for this video. In the next video, we have to understand. We understand today about point number 5 and 6. In the first video, we understand point 1 to 4. And in the next video, we are going to understand about the scheduler and controller manager, how they both are acting in our multi-master node.